Good morning. Today our lesson is about experimental probability. Our objective is to understand experimental probability, to understand the difference between theoretical probability and experimental probability. Let us remember what is the meaning of theoretical probability. If you have a coin, the coin has two possible outcomes, either heads or tails. So if you flip your coin, the probability of heads will be equal to the probability of tails, which is half, because it's one out of the two possible outcomes which we have it. Here we have used equally likely outcomes to calculate the probabilities. This way of calculation is called theoretical probability. Suppose now you flip the coin 10 times and you recorded the result. You got heads 7 times and tails 3 times. So the probability of getting heads here will be 7 out of 10. Why not half? Because you are depending on your experiment and you did the experiment here 10 times. So it will be 7 out of the 10 times that you flipped your coin. And the probability of getting tails, of course, will be 3 out of 10. A probability found in this way is called the experimental probability because you are depending on the experiment. So what's the meaning of experimental probability? To find an experimental probability, you must repeat the experiment a number of times. Each separate experiment carried out is called a trial. I have my own trial, you have your own trial, and your friend has his own trial. How to find it? We will divide the number of times the outcome occurs out of the total number of trials, like we did in the experimental probability when we flipped the coin. The number of times the head occurs was 7 out of the number of trials, which is 10 times. It is important to remember that when you repeat the experiment, the experimental probability will be slightly different each time. And the experimental probability of an event is an estimate of the theoretical probability. It is very near to the experimental probability, but it's not equal. And as the number of trials increases, the value of experimental probability will get closer to the theoretical probability. That's why scientists do many experiments in order to give us the final theory, which is the theoretical probability. After they did many experiments, they will get very closer to the theoretical probability. Example 1. Ollie throws an ordinary dice 300 times. The table shows his results. We know that the ordinary dice has 6 sides numbered from 1 to 6, and the frequency means here the number of times Ollie got 1, 2, 3, 4, 5, or 6. Of course, we have different times or different number or different frequency for each score. What is his experimental probability of throwing a 4? First of all, we need to know how many times or the total number of times Ollie throws an ordinary dice, which is 300. And if you add all the frequency here, it is also 300. The number of times Ollie gets 4 was 30. So it will be the probability of getting 4 will be the number of times 4 occurs out of the total number of trials, which is 300. So the probability will be equal to 30 out of 300, and we need to write our answer in simplest form. So we'll divide by 10 each numerator and denominator, and the answer will be 1 out of 10. Example 2. Maya spins a 5-sided spinner with sides numbered 1, 2, 3, 4, and 5. She spins the spinner 30 times and she records the results below. Use your table to find these probabilities. This is the table. It has possible outcomes and their frequencies. and they want us to find probability of an even number, probability of odd number, and probability of getting a square number. First of all, we need to add all frequencies to find out if the total is the same as mentioned in the example. The total here is 30, so yes, because Maya spins her spinner 30 times. Probability of getting an even number. Even numbers are 2, 4. So 2 we get it 4 times and 4 we get it 8 times. So probability will be equal to 12 out of the 30. If we simplify it, divide by 6 will be equal to 2 out of 5. Probability now of getting an odd number. Either you subtract 30 minus 12, which is 18, or you can get it also from the table, because odd numbers here are 1, 3, and 5. 1 we get it 2 times, 3 6 times, and 5 10 times. So 2 plus 6 is 8 plus 10, 18 out of 30, which will be equal to 3 out of 5. What is the probability of getting a square number? Square number means the outcome or the product of multiplying a number by itself. So 1 times 1 equal to 1. 1 is a square number. 2 times 2 is 4, so 4 is a square number. So here we have 1 and 4 are square numbers. 1 we get it 2 times, 4 we get it 8 times. So probability of getting a square number is 10 out of 30, which after simplifying will be 1 out of 3. Example 3, rolling a dice 50 times. The table here shows the outcomes of dice, which are 1, 2, 3, 4, 5, and 6, and their frequencies. And the total number of times was 50. From the table or from the results, we can estimate the probability of getting a 6, which is 1 out of 5. How? 10 out of 50 simplified will be equal to 1 out of 5. So the more you repeat the experiment, the more the data is reliable to use. Reliable means you can depend on the table to use it. As more as you repeat your experiment, as scientists do, as more as your data will be reliable to use. The question here, do you think the dice here is biased? What's the meaning of biased? Biased means not fair. Is our dice here not fair, biased? If the frequencies are very close to each other, means it is fair, means not biased. But if the frequencies here are different and very far, the result, the number of times we get 1 here is different from the number of times we get 3, or different from the number of times we get 4 or 6. So here we can say that the dice is biased or not fair, since getting 4 here 17 times is more than expected. 4 17 times is very far from the other results. Example 4. A company manufactures items for computers. The numbers of faulty items are recorded in this table. If you look, number of items produced, number of faulty items, and experimental probability. The experimental probability here for the first 100 items produced was 8 out of 100, which is 0.08. So the question was, complete the table. To complete the table, we will divide the number of faulty items by the number of items produced each time, of course. So 20 divided by 200 will be 1 out of 10, which is 0.1. 45 out of 500 will be equal to 0.09, and 82 out of 1000 will be equal to 0.082. Which is the best estimate for the probability of an item being faulty, and explain your answer. As we said in the previous slides, we said that as more as you repeat your experiment, as more as your experiment will be reliable. So here we will depend on the highest number of items produced, because it is the highest number of experiments that we did it. Here we will use the last result, which is 0.082 is the best estimate because as it based on the more results. More results here, the number of items produced, which is 1000. So if you want to get the best estimate, always go to the highest number of experiments. Example 5. A spinner has 4 sections, each labeled A, B, C, D. Susan and Helen spin the spinner a number of times. The table shows some information. From the table, we can see that Susan spins her spinner 20 times and she gets 8 times B. And Helen, she spins her spinner 120 times and the relative frequency is 0.35. What is the meaning of relative frequency? Relative frequency, students, is the same as experimental probability. So if you face the word relative frequency or find the relative frequency means find the experimental probability. Complete the table. Okay, to find the experimental probability for getting B for Susan, we will just divide the number of times we get B out of the total number of spins, which is 20 for Susan. So 8 out of 20 will be equal to 2 out of 5, which is 0.4. To find here the number of B's Helen gets, we will use the formula. We know that the experimental probability or the relative frequency is equal to the number of times we get B's out of the total number of spins for Helen, which is 120. So substitute in the formula here, number of B's out of 120 will be equal to 0.35. Now, to find the number of B's Helen gets, we will multiply or do inverse operation 0.35 by 120, which is 42. So Helen get 42 times B. As a plenary, our objective today was to understand the experimental probability depending on an experiment, and to understand the difference between theoretical probability and experimental probability. Example, if we have a probability of getting a 4 after rolling a dice will be 1 out of 6 because we have 6 possible outcomes and 4 is one of these 6. While to find the experimental probability, we will depend on the experiment and we will record our result in a table. Then to find experimental probability of getting 4, or it is the same as relative frequency, will be equal to 30 out of 300 because here the frequency, the total frequency is 300. 30 out of 300 will be equal to 1 out of 10, which equal to 0.1. Thank you very much.